All right, higher derivatives. So I just want to say I'm sorry for not having posted this earlier because I did tell you guys that I would. Although I did tell you sometime this weekend, I guess, but just didn't get around to it, so I'll make it up to you later. I'll get the next one out sooner, but just wanted to let you know that. So we're going to talk about higher derivatives in this video. Nothing really hard. I'm confident you guys can all do it and do it well. So don't worry, don't get stressed out or worried about it. Pretty easy concept. And if you don't get it right away, don't worry about it. We'll get to it in class. So don't worry about it, but just sort of a concept of something you need to know. So when we talk about higher derivatives, we're really just talking about second derivatives, third derivatives, fourth derivatives, and so on. And it's just that, first of all, important to know the notation. So you guys are used to Newton's notation, F prime, so F double prime. And again, don't worry about this. I know it can be confusing, so just let's have a look here. Let's just change that right now to make it a little more clear. It's F double prime and then F triple prime. There's three of them. If you want the fourth derivative, you'll sometimes actually begin to see it written in Roman numerals. So you'll see it. I think you guys know what Roman numerals are. You know, your 1 is like that, then your 2, and then your 3, then your 4, right? And then your 5, and your 6, and your 7, your 8, and you keep going from there. 9 is IX. So you guys know that, I think. So you'll see it sometimes like that, or you'll just see sometimes the numbers written in there. So if I want the 10th derivative, I literally just write f of 10 in brackets, so they kind of have an idea. If you're using Leibniz notation, now we haven't used this much, so don't worry if you don't get it right away, but your original derivative is dy over dx. So all we do is we put a degree number here and one here, okay? So we would go like this. That would be the fifth derivative, right? Because there's a 5 there. Do you get that? Hopefully you do. So that's the notation, okay? That's what it means. Now, how do you find them? So all you do, and this is nice, and I think that you guys are really bright, so you'll be fine with getting this. But you take the derivative. That's your first derivative. You get the second one. The second derivative, you just take the derivative of the first derivative. So you take the prime of f prime, and you take the derivative of the derivative. And then if you want the third one, you take the derivative again. And if you want the fourth one, you take the derivative again, and you just keep going. Now, there's not a lot of use for the higher derivatives. So the sixth derivative and the seventh derivative, we don't normally do much with those, if anything. But this f double prime, we're going to see that again. Okay, so just make sure you understand how to find that one for sure. And then, the other ones, it sort of follows, but they get a little messy after a while. And I don't want to stress you out. I don't want you to get upset. So we're not going to do anything other than, derivatives that are relatively straightforward, or anything bigger than the second derivative. So here's an example. Find the first 4 derivatives for x to the 6th. So first derivative, 6x to the 5. Power rule, right? You bring the 6 down, subtract 1 from the power. Okay. Just wanted to make sure you had enough time to think about it. I don't want to go too quickly. So now take a minute. If we think about the second derivative, it's the derivative of this now. So it's a power rule again. We're going to bring the 5 down. 6 times 5 is 30. And then 5 minus 1 is 4. So we get 30 x to the 4. Just checking my time to make sure that we're good. And then if we want to take the third derivative, because we want all 4 of them eventually, so same pattern, going to bring that 4 down there, and then subtract 1. So I get that, right? Because 4 times 30 is 120. And then we would go bring the 3 down. 3 times 120. And then subtract 1 from the power. So 3 times 120 is 360. And it's x squared. So I hope you get that. It's just a derivative after derivative. If you have any questions at all, obviously you can't ask them during the video, but maybe in the comments you can make a comment and say, I don't get this part, or maybe do another video about that, or you can just ask me in class, whatever works for you. Okay, I don't want to jump too quickly, but we are going to go to a function that's a little more difficult, okay, and just stay with me and I'll guide you through it, okay? So don't worry about it too much, but you want to find the second derivative of this function. So I'm going to start with the first derivative. I think you guys can handle this pretty well. Just bring the 2 down, you get 10x, and then the derivative of root x is 1 over 2 root x. Okay, and we've done that a number of times. I think you're good with that. Again, if you're not, just take your time, go back and check your notes, see what you got, see how I got that. But now we're going to get into the second derivative. So we're going to go this slowly because I don't want to lose you. So we're just going to look at 10x first. The derivative of 10x, the 10 stays, it's a constant, and the derivative of x is 1. So we're just going to have 10 times 1 plus. Now this one gets a little weird, so I'm going to just take it over here for a sec. I'm going to write this as 1/2 x to the negative 1/2. Okay? And that comes from really the derivative of this being x to the 1/2. So bringing the 1/2 down and subtracting 1 gets me to there. So to take the derivative of that, I'm going to bring the 1/2 down again. So I'm going to get minus 1/4. Okay. And then I'm going to subtract 1 from the power. So I'm going to get minus 3 over 2. And if you're wondering where I got that minus 1 minus 1/2, right? So 1 becomes 2 over 2. And that's where we get our minus 3 over 2. And then to simplify that just a little bit, that's 10 minus, and then 1 over 4 square root of x cubed. That's supposed to be 3. Okay, so there's my second derivative. All right, let's just check the time again, make sure we get lots of time. Yeah, okay, so we'll go to another example. Here's another example. It says find the third derivative. I'm going to change that. I don't want you guys to have to do too much here. You know, it is the weekend, and I know you're busy people, so we'll just go down to the second derivative. So here's what we're going to do first. We're going to do a chain rule this time, so don't, again, take it slow. But that's inside of this, so I got to do the 10th first. So I'm going to go 10, 2 minus x squared to the 9th. Okay, and then don't forget, right, it's multiplying by this, so we take the derivative of that, we get minus 2x. Okay, so that reduces down to minus 20x onto 2 minus x squared to the 9th. Then my second derivative, now this becomes a product rule. So again, don't get too upset, but we're just going to go through. There's my first function, okay, so minus 20x. Multiply by the derivative of the second. Now this guy's a chain rule again, okay, just like that one. So 9, 2 minus x squared to the 8th, and then times. Now don't forget, right, I know it's tricky, but you got to remember that chain rule. So you got to do this as minus 2x again, okay, and then it's plus, and now it's 2 minus x squared to the 9th multiplied by the derivative of minus 20x, and that's just minus 20. So to simplify this a little bit, minus 2 times minus 20 is 40. Then times 9, let's do that actually all in one step. I think you can handle it. You guys, pretty bright kids, right? So we don't need to worry about that. So 9 times 40 then, or 9 times 20 is 180, double is 360. And we have x squared on to 2 minus x squared to the 8th. And then it's minus 20 times 2 minus x squared to the 9th. Okay. And now this is fine, but you can factor out a 2 minus x squared to the 8th power. And if you do that, this becomes 360x squared. And this becomes minus 20 multiplied by 2 minus x squared. Oh, so we get 2 minus x squared to the 8th. And then you notice this is 360x squared minus 40, and then plus 20 more x squareds. And so we can actually put those together. And so we can make it 2 minus x squared to the 8th, and then multiplied by 380x squared minus 40. Okay, now we're going to do one more example. Pretty simple again, but I don't want you to freak out here. Don't worry if you don't get it right away, but I just want to show you what happens when we do it implicitly, okay? So we have xy plus sine y, and I still want to find y double prime, okay? We want to know what the second derivative is. So we start with the implicit differentiation. I'm going to go a little quicker because I'm running out of time, and I don't want you guys to not get the whole thing, but there's my first derivative. And then what I do is I have to group my y prime terms. And again, if you guys aren't following this, just ask tomorrow in class or whenever. Okay, we don't want anybody to be left behind, and I don't want anybody to be feeling upset or anything. So we'll work through it together. Don't worry. It's not that bad of a thing, but I think sometimes we get a little freaked out. We don't want that. So just, if this works for you, great. If it doesn't, we'll talk about it later. But there's the first derivative. And then what happens is I have to take the derivative of this. Okay, so y double prime then becomes the top and bottom functions now involve a quotient rule. So I do the bottom times the derivative of the top, and this one's a little funny. It's 2 to the x ln 2 times ln 2, because that ln 2 is a constant. So the derivative of 2 to the x is 2 to the x ln 2, and then it's times ln 2, and then it's minus y prime, and then that's minus the top, which is 2 to the x ln 2 minus y times the derivative of the bottom, and that's x. Whoops. Sorry, it's 1. Everybody makes mistakes sometimes, right? Including me. So here we go. This is 1, and then minus sine y, y prime, and divided by, x plus cosine y squared. So hope that was fun for you. Hope that makes sense to you. We're going to finish there. And you know what? Have a great rest of the weekend, guys. We'll see you on Monday, okay?